This is a solubility curve, and it does that. It tells us how soluble things are at different temperatures. And you'll notice as the temperature changes down here, your solubility, the grams able to dissolve in 100 grams of water, changes. For most solids, you'll notice as you increase the temperature, the solubility increases. If I look at KClO3, it starts down here. If you heat it up, follow this little curve, and it just increases the solubility. So all your solid lines are solids. The dashed lines are gases. And what you notice about them is the solubility of gases actually decreases as you increase the temperature. So we can use a chart like this to answer questions about saturation, how soluble things are, and such. So if you look at the first one up there, if I have 50 grams of HCl in 100 grams of water at 60 degrees Celsius, well, this chart is based on how much dissolves in 100 grams of water. So first thing you want to do is find HCl. That is right here. And at 60 degrees, this looks like the amount of HCl that will dissolve to make it saturated. If I read across, to me it looks like about 55 grams in 100 grams of water would make it saturated. Well, if I only have 50 grams, the solution would be considered unsaturated. Less is dissolved than what the solution can actually hold. The next one, potassium iodide. That's right here, top left. And it says, what kind of solution if I have 140 grams dissolved at 10 degrees? Well, at 10 degrees, it looks like, right there, I should be able to hold about 135 grams in 100 grams of water. Well, if I have 140, I'm above the line, I'm up here, so I have more than what I should have, and that would be considered super saturated. There's actually more dissolved than what there should be. The third question, how do you make a saturated solution of KCl? Well, this is my KCl line right over here. If I go to 80 degrees and read up, that's my mark. And then if I follow that across, to me it looks like we're about here. So I would say if you added 52 grams of KCl to 100 grams of water, it would be saturated. The fourth question says, where's the solubility of ammonia and potassium chlorate equal? Well, all you have to do is find ammonia. I'm going to mark that in red right here. And potassium chlorate, which I've already got marked in red. And if we follow these lines, here's my ammonia line. Where they intersect determines where the solubility is the same. So to me, it looks like the solubility is the same at around 58 degrees Celsius. And the last one says, how much potassium chloride is needed to saturate 250 grams of water? Well, again, what I can figure out from this chart is how much it takes to saturate 100 grams of water. So for KCl, which is my blue box right here, I'm going to go to 90 degrees. If I follow up from 90 degrees, it looks like we're right there. And I would say that is around 55 grams. 55 grams of KCl for every 100 grams of water. That would be saturated. However, I don't have 100 grams, I've got 250. So I want to figure out how much would saturate 250 grams of water. So this is just a simple ratio. 50 is to 100 as what is to 250. And when you cross multiply and divide, you'd come up with an answer of around 137.5 grams. So we can use this chart to determine how to make saturated solutions for any volume, even though the chart is only given right over here on the left side in terms of 100 grams of water. 250 is 2.5 times larger than 100, so I need 2.5 times more than what the chart says would be required to saturate it.